Hey there. I got a new tripod and this is going to be the first video that I'm filming on my phone, so let me know if the sound quality is better. Today we're going to talk about the graph of quadratic functions, specifically finding the vertex and the roots, both graphically and algebraically. Quadratic equations are written as ax squared plus bx plus c. This is the standard form for quadratic functions. This equation has a degree of 2, in this case the x squared. Think of a degree as the highest exponent that's going to be in the function. So in this case, the highest x degree is squared, or 2. So the degree is the greatest exponent. The graph of this equation is called a parabola. And it is a function. Parabolas are functions because since parabola is the graph has to pass the vertical line test. And if you forgot what that is from Algebra 1, when you have a parabola that opens up or that opens down, no matter where you draw a vertical line through it, remember a vertical line through that parabola, it will only hit the parabola in one point. So whether you draw it here or at the axis of symmetry or on the side, notice they only hit it in one point. And that tells us that it is a function. Another way to say that is there's only one output or y value for each input. Or x value. Follow along as we go through the rest of the notes. So now what we want to do is we want to graph this equation. So we can do it using a graphing calculator or desmos.com. So go ahead and do that right now. And you can see some important points that come up when we graph this equation. You'll notice that the axis of symmetry is at -1 and -9. And it reflects around that point. So when it's -2, it's -8. If you plugged into -3, -3 squared is 9, plus -6 would be 3, minus 8 would be -5. And you'll see when it's at -4, that's when you get 0. So go ahead and graph it. -4, 0, -3, -5, -2, -8, -1, -9. And then it reflects going back the other way. So go ahead and sketch a graph of your parabola. And we can use the table to help us write it. Okay, so let's draw in the axis of symmetry and find its equation. Remember, symmetry means where it's reflecting over. So where's the line where it reflects? Well, that line is right here at x equals -1. So what is its equation? X equals -1. And this equation of the axis of symmetry, since it will always be vertical, is always going to be x equals something. The formula for the axis of symmetry is right here. X equals -b over 2a. Make sure that you get this down. So to find the axis of symmetry, we could also do it algebraically. Use it to see if you get the same answer as in part B. Let's check. So we have to identify what is our A, B, and our C. remember we had standard form on the last slide. So our standard form using this is, remember, ax squared plus bx plus c. So our a value in this case is whatever's in front of the x squared. So our a value is actually just 1 because there's just one x squared. Our b value is right here in front of the x, so that's positive 2. And our c value, don't forget to use the sign that's before the number. Our c value is negative 8. So when we find our x, our axis of symmetry algebraically, we're going to be using negative b over 2a. Our b is 2, so x equals negative 2 over 2 times a, which is 1. So this simplifies to negative 2 over 2, or just negative 1. Hey, look, we got the same thing. X equals 1. So you can do it algebraically if you don't have a resource to graph with, or you can do it graphically by seeing where does that parabola reflect. Okay, here's D, E, and F. I'm just going to leave this graph up so that you can kind of refer to it during these. Okay, plot a point on the turning point. We know another word for this. It starts with a V, and that word is vertex. And label it A. So there's our vertex right there. That's point A. What is the coordinate? Well, if we go left 1 and down 9, the coordinate of the vertex would be negative 1, comma, negative 9. Our x value is negative 1, and our y value is negative 9. Let's think about this for a second. How does that coordinate relate to the equation of the axis of symmetry? Well, for the axis of symmetry, x is equal to negative 1, right? And you'll notice for the vertex, point A, the x is also equal to negative 1, right? The x is negative 1. And we have the y value, which is negative 9. So you'll get a little bit more information from the vertex, but if you'll notice, they have the x value in common, which makes sense, because the vertex is on the line of symmetry. Lastly, I want us to be able to find the zeros or the roots, both graphically, but also double check using algebra. So graphically, we can just look and think, okay, zeros, roots, that's where x is equal to 0. Excuse me, that's where y is equal to 0 on the x-axis. Here's a point at negative 4, comma 0. And here's a point at positive 2, comma 0. But sometimes that can be really hard to see on a graphing calculator. So there's a way that we can check also. On Desmos, it'll be pretty easy. You can just click on the points and they'll appear. But if you want to do this on a, on a graphing calculator, sometimes the scale is really small and it's a little hard to adjust. So let's look at how we can also do this algebraically. You might remember this from another class. But whenever we're trying to find the zeros or the roots, we want to try to factor, especially if we have a trinomial. And in this case, we do. The first part of the trinomial, the first term, is x squared. The second term was plus 2x. And the last term was minus 8. 1, 2, 3, trinomial. So let's go ahead and try and factor this. Remember, when we want to factor with a trinomial, we use the diamond method. And whenever you set up the diamond method, on top you want to put a times c, and on bottom you want to put b. That's how I remember b for bottom. So a times c would be 1 times negative 8, which is negative 8, and b on bottom would just be 2. So what I'm doing is I'm looking for two numbers that multiply to make negative 8, and then add to make positive 2. So the two things that I can think of are 1 times 8 that make this, or 2 times 4. Pause the video and try and figure out what two numbers go here. Okay, so what I'm going to do is I'm going to use 2 and 4 because I know there's a difference of 2 between those, but this has to be negative, so I think if I add these together, the bigger number takes precedence, so the bigger number must be positive. So this must be positive, which means this must be negative. Let's check. Negative 2 times 4 is negative 8. Negative 2 times 4, yep, that works. Negative 2 plus 4 is positive 2. Yeah, the bigger number is positive, we keep the sign, the difference is 2. Works out. So now we know how to write this in factored form. So this same quadratic equation written in factored form would be x minus 2 times x plus 4. Now, since anything times 0 is 0, if this whole thing was 0, this parentheses, then we'd have 0 times the second one. Or if this whole thing was 0, we'd have 0 times the first one. And that would make the entire thing 0. So when you're looking for the zeros, or the roots, what you're really thinking is, what would I plug in here to make these 0? Well, if I wanted to make this 0, I would plug in a positive 2. So x equals 2. If I wanted to make this 0, I would plug in a negative 4, positive 4. So my two roots are x equals negative 4 and x equals positive 2. Hey, look. My x value is negative 4 and my x value is positive 2. So now you can check algebraically and you can check graphically.